This instructional video is on topic 3 review pages. Number 1, is the relation shown in the table a function? So when we are identifying function versus not function, our rule is that each input can have one output. Remember, we know that the input is the letter X and the output is the letter Y. So each input, X, can have one output, Y. The X values can be used once. That was our shortcut. So for number 1, the input value 2 is only paired up with 1, 4 is only paired up with 2, 6 goes with 3, 4 goes with 8, and 10 goes with 3. None of the X values are used more than once, and so number 1 is a function. Number 2, does this relation represent a function? Use the arrow diagram and then explain your answer. So we can look at these ordered pairs, and we're looking at the X values, -5, 7, 3, 3, and 5, and we can see that no, it is not a function. It is not a function because the input values, the X values, 3 has more than one output. And we can make the map diagram to prove it. -5 and -3 get paired up together. 7 and 2 get paired up together. 3 and 8 get paired up together. But 3 also gets paired up with -8. So there are 2 arrows coming from that 3. And then 5 gets paired up with 10. So because there are 2 arrows coming from the same input, it is not a function. Mark has a $100 gift card to buy apps for his smartphone. Each week he buys one new app for $4.99. Write an equation that relates the amount left on the card, Y, over time, X. So we know our equation goes in the form Y equals MX plus B. The $100 would be our starting point. We start with our gift card, and then we are spending $4.99 each week. So the Y equals, it would be a -4.99x because we're spending the money, and then the $100 gift card is what we started with. So for our graph, we would go ahead and solve and graph our y-intercept first. So we would put our point at 100. $4.99 for each week would bring us to about $10 for week 2, and then $10 more for week 4, $10 more for week 6, $10 more for week 8. Again, I'm getting 10 because I'm rounding this $4.99 to 5. And 5 times 2 weeks gives me that -10. So I'm going down 10 and over the 2 weeks. So down 10 and over the 2 weeks. And so we can connect our dots, and we have our straight linear graph. Linear functions are shown. Which function has the greater initial value? So for graph A, the initial value is +2. For the table, we want the value of 0. So our pattern here would go 0, 1, 2, 3, 4. Going the opposite direction, 5, 3, 1, and -1, they're going down 2. So that puts our value at -3. And so function A has the greater rate of change. 2 is greater than -3. Now, for which function has the greater rate of change? The rate of change is our slope, -3. To find the slope of the table, we're counting our pattern. So that's a +1 across the top. It is a +2 across the bottom. We set it up as a fraction, y divided by x. 2 divided by 1 is 2. 2 is greater than -3. And so B has a greater rate of change. Number 1, what is the equation of a line that passes through those points and has a y-intercept of negative 0.5? We set up our equation in the form of slope-intercept form, y equals mx plus b, and we would plug in our values as given. Now, we know that we have a y-intercept of negative 0.5, but we would have to find our slope. When given ordered pairs, we can use the box method. 0.5 with 4.25 is our first ordered pair. 2 with the 18.5 is our second ordered pair. To go from 0.5 to 2, we're going up 1.5. To go from 18.5 to 4.25 is a value of 14.25. We set up our answer as a fraction, y over x, so 14.25 divided by the 1.5 to get a value of 9.5. So the 9.5 is our slope with our x value paired with it. Number 2, the graph shows the relationship of a number of gallons being drained from an aquarium over time. What function models the relationship? So again, we write our equation in slope-intercept form, y equals mx plus b. Our starting point at 90 is our y-intercept, so that's a plus 90. When we are solving the graph, we're going to pick out 2 points that we can read clearly. You can pick any 2 points on the graph. I'm going to pick this one here at 90, and I'm going to go down to this point here, which is at 1 and 80. Going from 90 to 80 is going down 10 and sideways 1. We set up that fraction as rise over run. 10 divided by 1 is 10, so that's a 10x. Because the slope of the line is going in a downward pattern, I know that my slope is going to be negative. It would be a negative 10x plus 90. The graph shows the altitude of an airplane over time. In which intervals is the graph of the function constant? So again, constant we know is a straight line. And so if we are looking at our graph, our straight lines come from 2, 4, and 6. So intervals 2, 4, and 6 are constant. For number 2, in which intervals are the graph of the function decreasing? Decreasing means going down. So that would be sections 5 and 7. It says Jack's mother brings him a bowl of carrots as a snack. At first, he does not eat any. Then he eats one at a time until half of the carrots are gone. Then he does not eat any more. Sketch a graph that shows the number of carrots in the bowl over time. So at first, it starts with a lot of carrots in the bowl. It says he doesn't eat any. So our number of carrots stays the same. It doesn't change. It is constant. As he eats the carrots, the line is going to go down because there are less and less carrots in the bowl. Once he eats half of the carrots, it says he does not eat anymore. So again, our line is going to balance out and remain steady at a constant rate because no more carrots are leaving the bowl.